Alright, what's going on, guys? Welcome to uh, my demonstration of, well, actually not my demonstration, but I'm just going to go over a quick overview of Page, our senior project. Yes, Page. P-A-G-E. Plant Automated Growing Environment, and that's basically what we have here. This is a 10-gallon water tank aquarium that's normally used for fish. Now what we're going to do is modify this tank. We're going to modify this tank. Inside of here there's going to be 2, 3, 4, how many ever plants you decide. I think we're going to use like 2 plants within a plant tray. Also there's going to be an irrigation system in here and everything, and you're pretty much going to be able to accurately grow your plants by controlling the temperature, the intensity, the amount of light it gets, the temperature, the watering frequency, humidity, and pretty much all that good stuff. I'm not really into plant growing, so that's not my field of expertise. My field of expertise is electronics, more specifically controls. And speaking of controls, controlling the Page system will be an Arduino Mega 2560, which we got from our wonderful Amazon. The 2560 will be controlling the inputs, outputs, and timing of all of the events that will take place within the Page system. Here's a custom input-output module that we are in the middle of making. I do have to note that the project is not really done yet. We're still in the early stages of designing and implementation, but pretty much this is how the product is coming along. We have to control the timing. We have the DS 1307 real-time clock module, which we picked up from SparkFun, which is going to allow the Arduino to know the exact date, day of the week, and time, and it would allow it to perform scheduled tasks such as watering the plants. If you want to water your plants every Tuesday at 12:24 p.m., the Arduino will be able to do that because it'll know exactly what time it is relevant to the world. The second chip right here is the ULN 2003A. It's basically a 7 array Darlington pair transistor chip. We're using that because the Arduino is only able to output a 5 volts at 40 milliamps, and we're running to run the all high power AC electronic circuits. We're using this relay card right here, which it requires 12 volts to turn on, and to offer electrical isolation from the actual relays. We're using this chip, which will drive this resistor, this relay card right here. This right here is our power electronics control panel. You have a 12 volt DC power supply, and then also the relay cards here, which are able to switch. There we go. Up to pretty good 125 volts AC at 15 amps, which none of our circuits hopefully will do. There's a couple of the terminal blocks and all that good stuff. We have a voltage regulator here, which will step down the 12 volts to 5 volts for the circuitry right here. Also in the middle of being programmed right now is the XB module, which will communicate with a host computer in the user's house that will allow that we'll be running our custom designed GUI, which was designed by Kelvin. It's really cool GUI that will allow you to change the temperature, humidity, turn the fans on and off, which we have right here. We have a 12 volt DC PC fan. It puts out roughly about 33 cubic feet per minute, which, you know, doesn't seem too bad. But yeah, the XB will be communicating, will be the bridge to allow the Mega to communicate with the host computer, and the GUI will be running on the host computer, and it will also have implementations to an iPhone app. So not only can you control your plants while you're in the house, but you can control them while you're across the country also. So whether, you know, you're in the living room, at your friend's house down the street, or at your grandmother's house across the country, you can know what's going on with your plants as far as what inputs or outputs are on, and if they're getting fed, or, you know, if they're getting watered and stuff like that. The lights have yet to be added yet. We created this holder right here, which is going to hold our 5 bulbs, 2 of which will be blue, 2 will be red, and 1 will be white. These will provide light and also some form of heat to the tank and the plants. And then also at the bottom of the tank, under the plants, will be a heat mat, which will be able to raise the temperature of the plants from from anywhere between 10 to 20 degrees above the above room temperature. And all of this will be controlled by the Arduino when it is to kick on and when is it to turn off, using these relays. To gain the temperature, we're using these 4 Maxim sensors. I'm sorry, I had a brain freeze for a second. But these 4 sensors right here are digital 1-wire, so that minimizes the amount of wiring that we're going to have to do. You only got to run a data line and ground wire. And these are digital temperature sensors with the accuracy of about half a degree Celsius. Accuracy isn't too important in this situation. We're looking, you know, to keep it within, you know, 1 to 2 degrees plus or minus is an acceptable range for our tank. These all communicate, like I said, over the Dallas 1-wire protocol, which will communicate with the Arduino via this resistor right here and this terminal block right here. Also, we will have a water tank on the side of the tank that houses a reservoir, a water pump, which will be controlled by this relay card and the Arduino Mega. That will contain a float sensor to allow you to know the exact level of the water, and to let you know if you need to refill your water, and we will alert the user, you know, when the water has gone to a certain level. Humidity will also be detected within the tank. We have a humidity sensor which we have to implement. But yeah, this is pretty much the first step and the first video of Page, which is a rapid, you know, we're working on it really, you know, vigorously, and hopefully it will be done sometime soon, so you guys can see the wonders of the Arduino Mega and Real World Electronics. So until my next post, this is Paige. Oh, and of course, some people don't use their computer 24/7, so to aid that, we created this cover, which will house an LCD and 4 function buttons, which will allow the user to navigate a menu that we'll create to allow you to turn on different inputs and outputs, and also monitor the tank remote, you know, from right here, so you don't even have to go to your computer to figure out, you know, the temperature of your tank. Whatever your GUI, your user interface sees, this LCD will display also. So this right here is Paige. More updates to come soon, more photos, and that's about it, and we hope to see you soon. Electro Discovery, only on WordPress.